My name is Jeffrey Kennedy, and welcome back to another episode of Market Academy. And this is the fifth and maybe the final week of our basic review of the wave principle. If you recall, starting 4 weeks ago now, we started looking at the impulse wave, this pattern right here. And then we followed up by discussing some of the intricacies of the ending diagonal. And then, of course, the zigzag. Last week we discussed the flat. So this week we're going to be focusing on the contracting triangle. So let's go ahead and move over, take a look at this page right here, and this is the diagram. And a triangle is actually very easy to identify on a price chart because it's basically denoted by sideways price action, specifically sideways price action within converging trend lines, as you see here. This is a typical contracting triangle. Now remember, the patterns that we look at as Elliotticians, some of these patterns are very similar to those old school patterns we read about in, say, Edwards and McGee and Bassetti, like, for example, those chart patterns, the head and shoulder, the rising wedge, and whatnot. Well, remember, those patterns are, say, a little bit more clearly defined or codified under the wave principle. And remember, each wave of a triangle, for example, subdivides into a zigzag, okay, specifically a zigzag. So you would have a three-wave move for wave A, three waves for B, C, D, and E. So this is why we would say use the notation 3, 3, 3, 3, 3 to identify the subdivisions within a contracting triangle. And remember, each one of those moves must be a triangle. Now, in some cases, one of those waves will be complex, i.e. a double zigzag. So for example, you could have a zigzag in wave A, ABC for A, a zigzag for wave B, ABC for B, and then in wave C, you'll see a complex correction. And that would be, again, a double zigzag. So that would be WXY. And then you would have wave D, and then, of course, wave E. Now, in rare instances, again, very rare actually, sometimes wave E will subdivide into a smaller contracting triangle. I've seen that on occasion, but again, it's one of those things that whenever you do see that or observe that on a price chart, it's kind of a rare event. It's kind of like watching, a shooting star or a meteor shower. They don't happen all the time, but whenever they do, they're kind of cool to watch. But again, basic triangle, and again, if you don't have that book, Elliott Wave Principle by A.J. Frost and Robert Prechter, you must pick it up because, again, in Chapter 2, that's probably the favorite portion of that book, page 86 to I think it's like 91 in Chapter 2. What Robert Prechter does is he goes through each one of those 5 core foundational patterns because, remember, this is what the wave principle is built upon. These are foundational, again, foundational patterns. Everything that we know about the wave principle starts here. And what he does in his book, which is brilliant, he goes through and says, okay, hey, here are all the rules which govern the development of an impulse wave. Here are all the rules which govern the development of a flat correction. Here are all the guidelines which are pertinent to, again, each individual actual pattern. So it's a very, very useful reference. That's why my copy of Elliott Wave Principle is always within arm's reach, because sometimes I might miss something or forget something or just want to double check something. Now, as you know, as we've discussed each one of these patterns, we've also, too, looked at some of the Fibonacci relationships common to each of those formations. For example, wave 3 of an impulse wave, typically 1.618 multiple of wave 1. Wave 5 and 1 tend toward equality. That basically is adheres to the guideline of wave equality, specifically pertaining to impulse wave development. We saw 2 or 3 weeks ago when we were looking at zigzags, we now know that, say, the most common Fibonacci retracement for wave B of a zigzag is a 382 retracement of wave A, followed by 618, second most common. Third most common, 50%. Well, here are the relationships, the Fibonacci relationships, we tend to find more often than not. Again, none of the Fibonacci relationships, retracements, multipliers, dividers that we use, none of those are rules. Those are all guidelines. Okay, very important to remember that. And the reason I say that is I once met an individual, fellow Elliottician, who, whenever he was working an impulsive structure, if wave 2 did not retrace to a 618 retracement of wave 1, he would not identify it as a wave 2. Well, that's a little bit too much of a strict adherence to, again, what is actually a guideline, because I've seen second waves go to 50% retracements, 786 retracements, and in very rare instances, 0.382. Okay, so again, these are guidelines, these are suggestions, and they're offered to essentially identify not a specific precise level, but a general neighborhood or region to look for reversals on your chart. Okay, so how far does wave B travel? Well, typically a 618 multiple or 618 retracement of wave A. How about wave C? Well, wave C typically equals a 618 multiple of wave A. Wave D equals a 618 multiple of wave B, and wave E equals a 618 multiple of wave C. Again, very simple to actually remember. Okay, now let's move on and take a look at a few other things that I think are very important to understand about triangles. Triangles are very limited to actually where they may occur. So that actually is a bit of a characteristic that we basically see within, say, ending diagonals. Because remember, an ending diagonal is limited to actually where it may actually occur. An ending diagonal can only occur in the fifth wave position of an impulse wave or as wave C of either a zigzag or flat. Okay, well, triangles are also too limited as to where they may actually occur. Triangles by themselves can only occur, for example, in a corrective position, such as wave 4. Okay, so in other words, you cannot have within an impulse wave 1, triangle 2, 3, 4, and 5. Can't do that. Okay, a triangle cannot represent the totality of a wave 2. Now you could have within wave 2, say A triangle BC, that would work, but you cannot have 1 triangle 2, 3, 4, 5. So that's a big no. Another thing that I think is very valuable about understanding triangles is that triangles always precede the final move of a sequence, which is why you find a triangle in the fourth wave position of an impulse wave, as wave B of, say, for example, a zigzag, or perhaps wave X. Okay, they always basically, whenever you see a triangle take shape, it's basically telling you that, hey, the party is almost over. It's not over yet, but it is almost over. And also, too, the triangle gives way to what we refer to the triangle thrust. Okay, the triangle thrust is the result of the actual triangle. Okay, so let's talk a little bit about the triangle thrust, because that's also too important to understand. How far will the triangle thrust move? Well, typically we look for a quality of the totality of the actual size of the pattern. Now, the way you come up with that is, rather than drawing your trend line from, say, left to right, you draw your trend line from right to left. So you start at wave D, go to wave B, and that goes over to the origin point of wave A. And then you go from C to A, draw that trend line to the left, and just drop a horizontal line down. So this is the widest portion of the triangle. And that will typically give you an idea of what we refer to as the triangle thrust. And again, I would probably offer that up as maybe, say, a minimum objective, because sometimes whenever you see a triangle, the thing about a triangle is whenever a triangle resolves, it either is going to be a kind of a smaller move or a very large move. Very rarely is it just kind of like an average move. But this is how you calculate the triangle measurement. Okay, now let's move on and take a look at some of the variations and complexities of the triangle, of which there are many. For example, the barrier triangle. Okay, the barrier triangle is easily identifiable because it has a very flat or horizontal BD trend line. So we have waves A, B, C, D, and E. Notice that that BD trend line is very flat. Now, one thing to keep in mind here is that it is allowable and it is okay if wave D of the triangle, of a barrier triangle, were to move briefly, that's the big takeaway, briefly, above the wave B extreme. This is very acceptable, okay? And it's also, too, very representative of real world markets, okay? It's nice if a market, stops and reverses at the tick of a 618 retracement, but very seldom does that actually occur. But this is a barrier triangle. And again, all a barrier triangle is, same thing as a contracting triangle, except the trend line, the BD trend line, is horizontal. Okay, let's move on and take a look at another variation. This is a common variation of a contracting triangle. It is referred to as a running triangle, okay? And it's a running triangle because wave B terminates above the origin point of wave A. Now, if this occurs, one thing that is a must is that the termination point of wave E of a running triangle must be below the origin point of wave A. Okay, keep that in mind. So you would have the origin point of wave A, 3 down for A, 3 up in B, C, D, E. B takes out the origin point of wave A, thus it's a running triangle. And then, of course, wave E must terminate below that wave A origin point. Typical running triangle. Okay, let's move on and take a look at another, say, variation of the triangle. And this was written about in one of Robert Prechter's newsletters, oh, probably 10 or 20 years ago. Very important point, something I see and recognize all the time. We refer to it as a truncated triangle. And the reason we call it a truncated triangle is because if you notice on this price chart, waves D and E, they're very small in comparison to the rest of the pattern. Okay, notice how long it took to complete waves A, B, and C. And then you have this tiny DE. Okay, that's referred to as a truncated triangle. Very, very common pattern. And of course, the most uncommon pattern that you actually see is the expanding triangle. Do they occur? Yes, they occur. But maybe within, say, maybe over the last 5 years, I've probably observed 3 legitimate expanding triangles over the last 5 years, maybe longer. I mean, again, it is a real pattern. They do indeed occur. I can't recall the last time I actually encountered one, but again, it does exist. But it's kind of a unicorn. So don't rely on this formation a lot because more often than not, there's a different way to actually count the pattern. For example, you might have, say, a 3-wave decline for wave A, 3-wave move up for an expanded flat B, and then it's a 5-wave decline for wave C. So, but again, rare pattern, does it exist? Yes, it does. But again, it's one of those unicorns. Okay. Well, that about does it for today. What I'm going to do tomorrow, again, is just kind of walk you through a few real examples of triangles on price charts. Okay. Well, that's about it for me for today, everyone. Thank you very, very much, and I'll see you tomorrow.